YouTube, what's going on with y'all, man? It's the fifth of OG Magic TV, and we're back. We're back with another video. But first, let me ask you this. Let me ask you a question. Have you ever wondered how you would perish if you were to perish on other planets? Not Earth, but other planets. If not, courtesy of the infographic show, they're going to let us know how it would be to perish on every planet out there in the atmosphere. But without further ado, let's get into this though. Let's get educated.
Have you noticed the trend of billionaires and influencers who seem to be dying to leave the Earth behind? Sure, their wealth and power might get them a first-class ticket off this planet before we boil ourselves alive due to global warming or thermonuclear war. But saying peace out to the pale blue dot isn't a guarantee of survival out there in the solar system. Here is what dying on every planet would be like, starting from the planet closest to the Sun. Mercury orbits the Sun at an average distance of 36 million miles, completing a full orbit in just 88 Earth days, making it the planet with the shortest year in the solar system. A single rotation, or one Mercury day, takes 59 Earth days. Its orbit is also highly elliptical, ranging from about 28.6 million to 43.5 million miles from the Sun. There's no atmosphere to speak of, and so no breathable air. There are also no moons due to the strong gravitational pull of the Sun. As your spaceship approached the planet, it would probably be sucked into the Sun by this force, incinerating the ship with you inside to a crisp within seconds. Mercury has a large metallic core, which takes up about 85% of the planet's radius of almost 1,300 miles, and it's likely partly molten or liquid. The core is covered by a barren, pockmarked outer shell about 250 miles thick. If you somehow manage to avoid getting pulled into the Sun and land on the planet, the first thing that'll kill you is the extreme temperatures. You might think that being so close to the Sun means extreme heat, and that is partially true. On the Sun-facing side, you would be faced with temperatures of up to 800 degrees Fahrenheit, which would literally cook you alive in seconds. But on the dark side of Mercury, the temperatures are no less extreme, albeit much, much colder. Temperatures there drop to negative 290 degrees Fahrenheit at midnight. NASA's latest spacesuit, the Exploration Extravehicular Mobility Unit, or XEMU, is designed to withstand temperature extremes ranging from negative 292 to 220 degrees Fahrenheit. Not quite enough to withstand Mercury's extremes, so even if you managed to survive the freezing conditions in the XEMU, you would be fried the moment the planet rotated. Venus, the second planet from the Sun, is the next stop. Orbiting at an average distance of about 67 million miles, it's about 0.7 times Earth's distance from the Sun. In many ways, it has characteristics quite similar to Earth. Venus has a diameter of around 7,500 miles, making it 95% the size of Earth. Its mass is roughly 81.5% that of Earth. But if the physical dimensions are roughly similar, conditions on the surface are most certainly not. The planet's atmosphere is dense and primarily composed of 96% carbon dioxide. Without a spacesuit, you would choke to death almost instantly. A truly nasty way to go. But even with a spacesuit, you wouldn't last more than a few seconds either. For starters, the atmosphere is composed largely of highly toxic sulfuric acid, which would likely dissolve your spaceship, your spacesuit, and then you. But even if your spaceship were made entirely of sulfuric acid-resistant metals like lead and tungsten, you wouldn't last more than a few seconds on the planet's surface. Although farther from the Sun, it's…
Hold on. Can y'all imagine that though? Can y'all imagine touching down on a planet, and as soon as you touch down, you start perishing? That's what I'm saying. I don't want that. No, I don't want that. That is crazy. Just know that, even with a spacesuit, you're done for. That shit is crazy. Nah, man. Nah.
It's even hotter than Mercury, at around 900 degrees Fahrenheit. That's 3.5 times hotter than NASA's best spacesuit can withstand. You would be burnt to ashes instantly, or rather what's left of you would, because the pressure would get to you before the extreme heat even had a chance. The air pressure on Venus is extremely high, reaching about 92 times the pressure at sea level on Earth, equivalent to 92 bar or 1,350 psi. That's similar to the pressure found almost 3,000 feet below the surface of the ocean on Earth. It makes Venus's atmosphere around 93 times thicker than Earth's.
Damn.
On the surface of Venus, all of that atmosphere above you would create immense pressure that would crush you instantly. That's the equivalent of over 1,300 pounds resting on 1 square inch of your body, or like having a small car sitting on your thumb. Bottom line, it would only take a millisecond before the pressure started crumbling your spacesuit, and after just 1 second your suit's integrity would be compromised. You would be trapped in the imploding spacesuit with no way out. The third planet of the Sun is, of course, Earth. But what about dying on Earth's moon? Sure, you don't have the crushing pressure and extreme heat of Venus or the extreme temperatures of Mercury to contend with, but the moon has a very thin layer of gases on its surface, which is technically considered an exosphere rather than a traditional atmosphere. This exosphere is so sparse that it exerts negligible air pressure, with the surface pressure at night estimated to be around 3 times 10 to the power of negative 15 bar. Surface temperatures vary dramatically between day and night, spiking to about 260 degrees Fahrenheit during the day and plummeting to negative 280 degrees Fahrenheit at night. Your NASA spacesuit can more or less handle that, but in the deep craters near the moon's poles, temperatures can drop to below negative 410 degrees Fahrenheit. You would be frozen solid within minutes if you fell into one. The biggest threat to your life on the moon's surface is the fine gray dust that covers it. This lunar dust is known as regolith. It covers virtually the entire lunar surface from a depth of about 6.6 feet to perhaps 66 feet or more. It includes everything from the huge boulders to particles only a few nanometers in diameter. But most of it is a puree created by uncountable high-speed micrometeorites that have been crashing into the moon unimpeded by the atmosphere for more than 3 billion years. Eons of melting, cooling, and agglomerating have transformed the glass particles in the regolith into a jagged-edged, abrasive powder that clings to anything it touches. It packs together so densely that it becomes extremely hard to work at any depth below 4 inches. That makes regolith an all-pervasive, pernicious threat to machinery and human tissue alike. During the 1969 moon landing, after just 3 days of moonwalks, regolith threatened to grind the joints of the Apollo astronauts' spacesuits to a halt. Breathing it can cause pulmonary fibrosis, the lunar equivalent of black lung, and it's only a matter of time before you succumb to this excruciatingly painful death once you leave that spaceship. So, you'd last a lot longer on the moon than you would on Venus or Mercury, but the quicker death would likely be merciful. Mars is the next planet, and you'd also have a chance of surviving for a bit longer here. Or, in other words, you could look forward to a slower, more drawn-out death like on the moon. Mars is probably the most survivable surface conditions of anywhere in the solar system except Earth.
Time out. See, why do I want my death to just linger? I don't want that. I want that to be swift. Get me out of there. Does that gone. Get me out of there. That's all I want. You know what I'm saying? I'm not trying to suffocate slowly. I'm not trying to hit a planet, just get squished. I'm not trying to do none of that shit. I'm not trying to do none of that. So I'm just like, man, if I was to go to a planet, just take me to one to where I'm gone instantly. You know what I'm saying? I ain't trying to be slowly dying and think about life and why I'm on this planet, why I picked this planet, all that. You know what I'm saying? I'm not trying to have none of that. So, yeah, I would definitely just take the easy, quick way out. Just saying.
With temperatures reaching a pleasant 70 degrees Fahrenheit in the summer, although they do plunge to negative 200 degrees Fahrenheit at the poles. However, even if you landed on the equator in the summer, you wouldn't last long. Here, it's not the pressure or the temperatures or the dust that'll do it to you, but the atmosphere. The atmospheric density on Mars varies wildly, ranging from a low of 30 pascals on Olympus Mons to over 1,155 pascals on Hellas Planitia, with a mean pressure at the surface level of 600 pascals. The average surface pressure is about 610 pascals, around 0.6% of Earth's atmospheric pressure. That means that Mars's atmosphere is over 100 times thinner than the Earth's, making it extremely difficult to breathe here. What's worse is it's 95% carbon dioxide. with smatterings of nitrogen, argon, oxygen, carbon monoxide, and water vapor. And carbon dioxide poisoning is a truly terrifying way to die. At concentrations above 10%, carbon dioxide can cause convulsions, coma, and death. Concentrations above 30% can lead to a loss of consciousness in seconds. So thankfully, at 95% concentration, you would pass out before the lack of oxygen killed you, a matter of minutes. And that's because carbon dioxide builds up in your blood as you breathe. You experience the stressful sensation of breathlessness before losing consciousness. You die in a state of panic, gasping for oxygen that just isn't there.
See?
If you thought that was bad,
cool.
death on Jupiter will come as a real shock, the electrical kind. Jupiter is the largest planet in our solar system, with a diameter of close to 89,000 miles at its equator, giving it a volume of 1,321 times that of the Earth. It has 95 known natural satellites, and its atmosphere is approximately 76% hydrogen and 24% helium by mass, and about 90% hydrogen and 10% helium by volume. The big difference here compared to the planets we've looked at so far is that underneath all that atmosphere, there is no solid ground, just denser and denser concentrations of toxic gases. That means that the pressure at the core of Jupiter is so high that it would be like having 160,000 cars stacked on top of each other and then all of them on top of you. Obviously, you would be crushed long before you reached the core, but the chances are you'd be dead even before that, as your spaceship crumpled from the pressure. At temperatures around negative 234 degrees Fahrenheit in Jupiter's massive gas clouds, your spacesuit might survive the descent toward the center, even if your spaceship didn't. And since there's very little carbon dioxide in this toxic mix of hydrogen, helium, methane, and water vapor, at least you wouldn't experience breathlessness before you passed out and then were crushed by the pressure. But most likely, you'd be killed by lightning before that even happened. Jupiter's lightning activity is closely tied to its atmospheric dynamics, with powerful updrafts and strong winds contributing to the formation of electrical storms. These thunderstorms can be wider than the Earth, creating incredibly powerful lightning. When a bolt inevitably hits your descending spaceship, everything inside, including you, would be fried in milliseconds. Like Jupiter, Saturn is also a gas giant, without any solid ground at its core. The temperature of Saturn's core is thought to be around 15,000 degrees Fahrenheit, guaranteeing an instantaneous death by incineration that would likely be too quick for you to even experience. But you wouldn't get anywhere near that core before the planet's extremely hostile conditions put an end to you. That's because to reach the core, you'd have to pass through Saturn's rings. Saturn's rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet. They were torn apart by Saturn's powerful gravity. They're made of billions of small chunks of ice and rock, coated with other materials such as dust, ranging from tiny dust-sized icy grains to chunks as big as a house or even a mountain. Saturn's ring system extends up to 175,000 miles from the planet, so it would take your spaceship months, if not even years, just to travel through them. That is, if hypothetically the advanced materials and navigation systems needed for the trip were developed. It's not to mention the extreme winds. Winds in the upper atmosphere reach 1,600 feet per second in the equatorial region. By contrast, the strongest hurricane-force winds on Earth top out at about 360 feet per second, and the pressure is so powerful that it squeezes gas into a liquid. So, descending through the rings means getting pummeled by all manner of space debris. Then it's a matter of when, not if, you get hit by something large and heavy enough to destroy your ship. From there, the pressure and temperature will cause you a painful but thankfully quick demise. That's not necessarily the case on Uranus. Uranus is known as an ice giant. That means 80% or more of the planet's mass is a hot, dense fluid composed of icy materials including water, methane, and ammonia. This material isn't ice in the conventional sense. Rather, it's more like a kind of compressed slurry. Like the other planets that we've considered, you have all the same risks of death by extreme temperatures, atmospheric pressure, and toxic gases. In its innermost parts, Uranus has a small rocky core that heats up to 9,000 degrees Fahrenheit. Meanwhile, the atmospheric pressure is extremely high, with the surface pressure being greater than 1,000 bars. The atmosphere of Uranus is primarily composed of hydrogen and helium with 2% methane, a combination that gives the planet its cyan color. Now, that 2% methane might not sound like a whole lot, but it is concentrated enough to kill you within minutes. Should you somehow survive all of that to reach close to the planet's core, there is a much more exotic death awaiting you. The extreme temperatures and the pressures surrounding the core mean that it is probably enveloped in elements that are compressed into exotic quantum states. Their quantum weirdness transitions into a super-pressurized soup that thins out the closer they get to the surface. This extreme pressure and atmospheric weirdness would literally compress you into a kind of human diamond. You might last forever, but you wouldn't be conscious to experience it. Next up is Neptune, which looks a lot like Uranus, but Neptune has a life-ending phenomenon that Uranus does not: extreme winds. To be fair, Uranus's winds are no joke either, reaching speeds of up to 560 miles per hour near the equator. But Neptune is known for having the strongest winds in the solar system, with wind speeds reaching up to 1,200 miles per hour near its great dark spot. These winds are faster than the speed of sound on Earth, but they do not exceed the speed of sound on Neptune due to the higher density of its atmosphere. They're also driven by energy from the planet's core rather than solar radiation, as Neptune is rather far from the Sun. Neptune's atmosphere plunges to almost 3,700 miles below the point where the pressure matches Earth's sea level. It reaches depths where the pressure exceeds 1,000,000 times what we experience on Earth. The temperatures reach as low as from around negative 370 degrees Fahrenheit, well below what NASA's latest suit can withstand. Neptune's atmosphere is composed predominantly of hydrogen and helium, which contribute nearly to 98% of the atmospheric molecules. The remaining 2% consists mostly of methane gas, exposure to which, as we've already seen, will undoubtedly kill you quickly. But the winds will almost certainly get you first. In addition to the extreme speeds, they're also turbulent, creating swirling vortices that would throw your spaceship in different directions. Combined with methane ice in the atmosphere, they would rip the ship apart. And if you happen to get sucked into the Neptunian supersonic vortex, the ship would start spinning violently. Under intense pressure, your organs would become increasingly compressed inside your body. Your blood would pool around your legs and would cause oxygen deprivation to your brain. It's a horrible and excruciating death. We've now reached the outer limits of the solar system to the dwarf planet Pluto. Most people will have grown up with Pluto considered as the 9th planet in our solar system. However, it was reclassified as a dwarf planet in 2006 by the International Astronomical Union because it doesn't meet the criteria for a planet, which includes clearing the neighborhood around its orbit. Pluto is now considered the largest known dwarf planet in the solar system, and it's located an astounding average distance of 3.7 billion miles from the Sun. It orbits within a region of icy objects known as the Kuiper Belt. That means with current technology, it would take a manned mission probably 20 years to reach it from Earth. So, death by boredom is a factor that might come into play for the astronauts on board. Should you survive the long cold journey, there's no shortage of hazards that would kill you once you arrive. Despite being smaller than Earth's moon, around 1,400 miles in diameter, the dwarf planet maintains a thin atmosphere composed mainly of nitrogen, methane, and carbon monoxide. So death within minutes from a lack of oxygen is a definite possibility. Pluto's surface temperature is around negative 387 degrees Fahrenheit, making it one of the coldest places in the solar system. This extreme cold can freeze most substances, including nitrogen, methane, carbon monoxide, and of course humans. But like Neptune, Pluto's orbit is also highly elliptical and tilted relative to the plane of the solar system. That means that this dwarf planet's distance from the Sun varies significantly, leading to extreme seasonal changes and making it difficult to predict and plan for the environmental conditions. As it is, the surface of Pluto is covered in frozen nitrogen, methane, and carbon monoxide, with mountains and plains that are relatively young geologically. That makes the surface rugged and extremely hazardous for landing and exploration. Chances are high that you would crash land into a jagged methane mountain and then die of a combination of extreme cold, methane poisoning, and a lack of oxygen within seconds. Arguably, the biggest threat to your life is the phenomenon of tidal locking on Pluto. The planet and its largest moon, Charon, are tidally locked, meaning that they always show the same face to each other. This can create unique gravitational effects and tidal forces that could either grab your ship and smash it down into that inhospitable surface, or just crush it like an empty soda. Finally, we arrive at 2018 AG-37, appropriately nicknamed Far Far Out, This is the most distant known object in our solar system, orbiting at an average distance of 132 astronomical units from the Sun. But its orbit is highly elliptical, ranging from 27 AU to 175 AU, which means that it takes about 1,000 years to complete one orbit.
Shit.
A major factor at play here is the gravitational influence of Neptune, which has likely played a role in shaping Far Far Out's widely divergent orbit. Far Far Out's orbit crosses paths with Neptune, meaning gravitational interactions between the two could eventually shift its trajectory or even lead to risky close encounters. If you timed your approach into this cold, faraway 248-mile diameter ice rock wrong, you could be exposed to insane life-ending atmospheric pressure, gravitational effects, and tidal forces. However, the major known threat to human life is its extreme distance from Earth. Far Far Out is nearly 4 times farther from the Sun than Pluto, which orbits at an average distance of about 39 AU. So, without some kind of cryogenic technology to keep you asleep and young on the long voyage, you'll most probably die of old age before you get anywhere near it. And that is if all the many
960
hazards
years.
presented by the journey don't get you first. Radiation from solar winds
Come on,
and galactic cosmic rays can cause illness and damage organs. Long-term exposure to microgravity can lead to muscle atrophy, deterioration of your skeleton, and changes in fluid distribution. And the effects of spaceflight on the human body are harmful even in the short term, with significant adverse effects including bone loss, heightened cancer risk, vision impairment, and mental health issues. All things considered, it might be better to die within seconds from freezing, burning, or being crushed than to
Yes.
waste away in a
Yes.
high-tech tin can hurtling through space
Yes, I
without
agree.
much hope of ever reaching your destination in one piece. But what do you think? Which planet offers the most gruesome and painful way to die? Which would you prefer if you had the choice? Let us know in the comments, and thanks for watching. Now go check out What If the Earth Stopped Spinning Minute by Minute, or click on this video instead.
So let me tell y'all something. Let me tell you something. If I had to choose how to go out, I think I would just rather hit a planet and that planet just crush me. That's it. No pain, no nothing. Because from what he was saying, it's damn near instant. You know what I'm saying? It's damn near instant. So it's damn near instant. You touch down, gone, done. You know what I'm saying? I would choose that. I'm just saying though. Man, but I was educated, you know, I mean, hopefully y'all were too. I mean, I knew about planets, but it really wasn't my jam in school. You know what I mean? So to really just find out that, you know, the pressures on certain planets, you know, how hard the wind blow, how certain planets is pretty much just gas. I mean, that right there is interesting to me. But hopefully y'all liked this video. Please share, drop a comment. Definitely think about subscribing, and I'm gonna see y'all in the next video. Deuces.